Hola, are you ready? We're fixing to do lesson 1.4. I just wanted to say hi to you. So I'm taking this camera off, but I'm really here. So lesson 1.4 is measuring segments and angles. And we already know what segments are. So how do we find the lengths of segments? So I just put a picture up here of segment AB. Here's a line segment. The rule or postulate 1.5 says the points of a line can be put into one-to-one correspondence with real numbers so that the distance between any 2 points is the absolute value of the distance of the corresponding numbers. And that's just a fancy long way of saying I'm going to take my 2 points and subtract them and find the absolute value. I've got my coordinate A, that's my point A, B, subtract them, and that's going to be the length of that line segment. I love how mathematicians make things sound really fancy like this postulate. So if I move on down, if I have 2 line segments that are the same length, the mathematical term for that is congruent. If you can see that right down here, they're congruent. This is the congruent symbol. It looks like the equal sign with the little squiggly mark above it. And be sure you are writing all this down. Press the pause button, get this down in your notes, in your whisk. So if I show you an example of comparing segment lengths, we've got this line here with a bunch of different segments, and we're going to compare AB to BC. So if I look at AB, I have to subtract -8, take away -5, which you can see right here. And when you work that out, you're going to take the absolute value of it. So you're taking the absolute value of -3, which is 3. And I want to compare that to the length of BC. Well, BC, you need to take -5, take away -2. When you do that within the absolute value, you get -3, so you need the absolute value of -3, which is 3. So you can say that AB is equal to BC. Or another way to say it, segment AB is congruent to BC. All right, so we have another postulate, and this is a pretty simple, straightforward one. It's called the segment addition postulate. If 3 points A, B, and C are collinear, they're on the same line, and B is between A and C, that means you could take segment AB and add it to segment BC, and you get segment AC. That's not too hard. So you can use that to solve some equations when asked, such as, for example, if I told you that this entire segment AC was equal to 60, and I asked you to find X and then find A and B, the length of segment AB and the length of BC. And I tell you that the length of segment AB is 2x minus 8, and the length of BC is 3x minus 12. Well, I know that the entire length is 60, so I can put A, B, and BC together and equal it to 60. So what I've done that right over here. 2x minus 8, that's AB, add it to 3x minus 12, which is BC, and that equals 60. And if I do my algebra, which y'all should know, I'm going to find that x equals 16. So when I put 16 in for x, right here for AB and right here for BC, I can solve that and find that AB equals 24 and that BC equals 36. All right, if we move on down, we're going to talk about midpoints. A midpoint of a segment is a point that divides a segment into 2 congruent segments. That means they're equal. A midpoint or any line, ray, or other segment through a midpoint is said to bisect the segment. So since this is the midpoint, segment AM is congruent to segment MB. And so if I assigned values to those, let's say I said that segment AM is 2x plus 1, and I say that segment MB is 3x minus 4, I can set them equal to each other because this is the midpoint, and I can solve for whatever x is. So when I do that through my algebra skills, I get that 5 is equal to x, and so I substitute that back in, and now I find that segment AM is equal to 11 and segment MB is equal to 11. All right, we're going to move on down and talk about angles now. I put this picture in because look at all those angles on this roller coaster. And I picked this roller coaster because I've ridden both of these before. This is the Loch Ness Monster in Busch Gardens in Williamsburg, Tennessee. This is called the Drachenfeier. Now, whoever built the Loch Ness Monster did a good job because it's still up and running. But whoever built the Drachenfeier made a bad mistake. I've ridden this thing and I blacked out on it twice. And it only lasted 5 years, and somebody died on this, and they had to take it down. So they must not have understood the angles correctly. So angles, sorry for that sad note, but I just wanted to put that in there because it's relevant to me. Angles are two rays with the same endpoint, as you can see in this illustration. The rays are the sides of the angle, and the endpoint is the vertex. So the way they're named, I could name this one angle A, or I could name it angle CAB, or I could name it angle BAC. You want the vertex point in the middle of your angle name. Angles are measured in degrees, and so the way I would write that is the measurement of angle A is 60 degrees. I just made that up. It looks like it's 60 degrees. Now we have a postulate. It's called the protractor postulate. We're going to be using those to measure some angles. 1.7, it's, remember they like to word these fancy. O, here's O, is a point with opposite rays. See the opposite rays? OA is this to the left, and OB is going to the right. Any ray drawn up from O creates an angle with a measure somewhere between 0 and 180 degrees, because a straight line is 180 degrees. And remember, when we're measuring the angles, we need to take the absolute value between the 2 points when we subtract them. Now, the 4 most common types of angles are acute angles. Those are angles whose measure is less than 90 degrees. You need to write this down. Right angles are angles whose measure exactly 90 degrees, and you show that by drawing the box at the vertex of the angle. An obtuse angle is an angle whose measure is between 90 degrees and 180 degrees. So it's bigger than a right angle, but not quite 180 yet. And a straight line, of course, is an angle that is exactly 180 degrees, which makes it flat. Now, postulate 1.8 deals with these angles. It's the angle addition postulate. And it simply says if a point B, right here, is in the interior, that means the inside of angle AOC, then angle AOB plus the measurement of angle BOC is going to equal the measurement of the biggest angle, AOC. And if angle AOC, notice as a flat straight line, is a straight line, then the measurement of angle AOB and BOC equals 180 degrees. And you could use this to figure out different angles if you know one, just like these examples show you. We're not going to work those out right now. We'll be working those out in class. All right, lastly, we're going to talk about congruent angles. Those, I forgot to write that down. I'm going to write that down for you right now. These are congruent angles. And that just means they equal each other. And this is how you would write it. Angle A is congruent to angle B because their measurements are equal. And I just threw this picture in because I love when the Blue Angels, I used to want to be an airplane pilot, and I've flown airplanes before. There's you another fact about me. Notice when they fly, these angles better be congruent or we're going to have a bad disaster going on. So I hope you enjoyed this lesson. We'll be doing lots of work with angles and measuring segments and angles soon. Talk to you later.